After reading this question, now let's label those quantities given. 8.46 moles, that's the number of moles. And pressure, 0.990 atmosphere, so that's P. Obviously, this is a temperature, 25 degrees Celsius. Now what is asked? Volume. We know temperature, we know the number of moles, and we know the pressure. We just need to find out the volume. One of the couple of key gas law equations is this. This is the ideal gas law equation. PV equals nRT. And in this question, we need to find out the volume. We need to find out V. So then from this key equation, we can develop this equation, all right? So V equals, we keep everything nRT on the other side, then move the P to the other side as the denominator. Okay, the number of moles, 8.46. N times R. R is actually the gas constant. So here is the value. And pay attention to the units. Please note that there are actually two gas constants. Actually, then using two different units. Okay, so and in this case right here, since we have the pressure units in ATM, and then the volume unit is in liter, and then we have moles, and then of course temperature in Kelvin. So that's why we use this 0.082. This value, this constant, always goes with this set of units. Okay, there's another one with a different value and different units. If you feel it's kind of difficult to remember these units, actually, there's an easy way to fix that problem. Again, this is the key equation for ideal gas law. And now the gas constant, PV over NT, that should be always a constant, should be always the same, depending on, of course, what kind of units you use, for P and V. So then you would get a different value. That's why you use different units. But in this case right here, you see, okay, R, the units should carry volume, liter, or in this case, we just go with this order. So the unit should be, okay, pressure should be in atmosphere. And then the volume should be in liter. And the number of moles should be N. Actually, N should be MOL. And then the temperature should be in Kelvin. And look at that. So this is the unit for this R constant, 0.082. And you see right here, this unit is the same as this one, even though the ATM and liter, so the position got swapped in these two locations, two different steps, but so that's the same. Okay, so now NR, then also multiply by the temperature, 25 degrees Celsius. Again, you always convert that to Kelvin. Then divided by the pressure, which is 0.990 atmosphere. Now let's take a look at those units. Moles, they are gone. Kelvin, also gone. And then atmosphere, also cancel. So only, of course, liters right here remains as the unit for the final answer. Okay, so therefore 209 liters, that should be the correct answer for this question.